Hello friends, myself Rajendra Mahajan presenting my video on one-shot revision of ordinary differential types. Example number 1, solve differential equation y multiplied by 1 plus 1 by x plus cos y into dx plus x plus log x minus x sin y into dy is equals to 0. Let us try to solve this problem. The given differential equation is y into 1 plus 1 by x plus cos y into dx plus x plus log x minus x sin y into dy equals to 0. It is in the form of m into dx plus n into dy equals to 0. That is general form of exact differential equation. Then comparing that two equations, we get the value of m as y multiplied by 1 plus 1 by x plus cos y, and the value of n as x plus log x minus x sin y. Then differentiating m with respect to y, keeping x constant, derivative of the first term is 1 plus 1 by x and derivative of cos is minus sin y. Differentiating n with respect to x partially, keeping y constant, and therefore the derivative of x plus 1 log x is 1 plus 1 by x and minus sin y. These two values are equal, and as these two values are equal, given equation is exact differential equation, first type. Then we have to obtain the solution by performing these two integrals. Integration of m with respect to x, nothing but integration of y into 1 plus 1 by x plus cos y with respect to x. Y is constant term taking outside. Integration of 1 is x. Integration of 1 by x is log x. And cos y constant term outside. Integration of dx is x. And we call this equation 1. Then second integral is terms in n which are free from x. And then we have to integrate it with respect to y. Therefore, we check, is there any term which is free from x? And there is no any term which is free from x. And therefore, as no term, its integration is 0. Equation number 2. And therefore, a solution is obtained by adding equation 1 and equation 2 and then equating it to c. And therefore, we get the final solution as y multiplied by x plus log x plus x cos y equals to c as the required answer. Example number 2, solve differential equation as dx by dy plus 5x divided by y is equals to 1 by y square. Given differential equation we call as equation number 1 with x as dependent variable and y as independent variable. Rewriting it as dx by dy is equals to 1 by y square minus 5x by y. Taking LCM as y square, we get 1 minus 5xy divided by y square. Transferring that y square to left hand side, we get y square into dx minus 1 minus 5xy into dy equals to 0. Again, I have converted it into the form of mdx plus ndy equals to 0. Why? To check whether it is exact or not. Therefore, here m is y square, n is 5xy minus 1. Differentiating m with respect to y, we get derivative as 2y. Differentiation of n with respect to x is 5y. A value are not equal, and therefore equation is not exact. And as it is not exact, we have to think for some other technique. Next technique is linear. We check whether the equation is linear in y or linear in x. Here x is dependent variable and y is independent variable. That once again I will write that equation, dx by dy plus 5x divided by y is equals to 1 by y square. Here x is with degree 1 and its differential coefficient, its degree is also 1. That is the first condition for linear differential equation. Dependent variable and its differential coefficient must be with degree 1 and not multiplied together. These two terms are not multiplied together, whatever the simplification we perform. And therefore, the given equation is a linear differential equation in x. In x means with x as a dependent variable. Then comparing it with the general form as dx by dy plus p into x is equals to q, where the p is the coefficient of x and q is the value on the right hand side. For this particular example, p is 5 by y and the q is 1 by y square. After getting these two values, we find integrating factor, nothing but multiplying factor, by e raised to integration of p with respect to y. Here it is integration of 5 by y with respect to y. It is e raised to 5 log y. As per the laws of logarithm, it becomes e raised to log of y raised to 5. E and log get cancelled. We get that if as y raised to 5. Then the solution is obtained by formalize dependent variable into if is equals to a plus q into if with respect to y, substituting the dependent variable as x, if as y raised to 5 is equals to a plus integration of q is 1 by y raised to 1 by y square, if is y raised to 5. It becomes integration of y cube with respect to y and value is y raised to 4 by 4. Therefore, the required solution is x is equals to a divided by y raised to 5 plus 1 by 4 y raised to 4 by y raised to 5. It becomes a into y raised to minus 5 plus 1 by 4 y raised to minus 1 as the required solution. Example number 3, solve equation as e raised to minus x into secant square x dx is equals to dy plus y into dx. There are two terms of dx. Combining that two terms, we get equation as e raised to minus x secant square x and minus y into dx is equals to dy. Or transferring it to left, we get minus dy equals to 0 in the form of mdx plus ndy. Comparing these two equations, we get the value of m as coefficient of dx e raised to minus x secant square x minus y and n as minus 1. Differentiating m partially with respect to y, we get that value as minus 1 and derivative of n with respect to x as 0. These two values are not equal and therefore equation is not exact. And as it is not exact, we have to check whether it is linear in x or linear in y. Therefore, if we see the term of y, its degree is 1. Therefore, it may be a linear in y. And degree of x is not possible as it is non-linear term. And therefore, as it is linear in y, we rewrite it in its general form as dy by dx plus py is equals to q, and therefore rewriting that equation we get dy by dx or e raised to minus x into secant square x minus y into dx is equals to dy. dividing by dx throughout, we get dy by dx is equals to e raised to minus x into secant square x minus y. Then transferring that y terms to left hand side, we get dy by dx plus y is equals to e raised to minus x into secant square x, equation number 1. Therefore, y dependent, x is independent variable, p is the coefficient of that y, here is 1, and q the value on the right hand side, it is e raised to minus x into secant square x. Integrating factor, therefore, e raised to integration of p with respect to x, it is e raised to integration of 1 with respect to x, it becomes e raised to x. And therefore, solution is given by dependent variable into if is equals to a constant plus q into if and its integration with respect to x. Dependent variable is y. If we have e raised to x is equals to a plus integration of q. Q is e raised to minus x into secant square x and into if e raised to x. It is integration of secant square x with respect to x as tan x. Example number 4. Solve differential equation as dy by dx plus y by x is equals to y square divided by x square. Its solution as a given equation we call as equation number 1. Here y is a dependent variable, x is independent. To check it whether it is linear in y or linear in x, we find the degree of x and y. Here the degree of y is 2 and degree of x is also 2. Therefore, equation is neither linear in y nor in x. Means we have to think for some new technique. And we go for the next technique as equations reducible to a linear. And for that purpose, we try to divide the equation by, or we convert in this form, dy by dx plus py is equals to q into y raised to n. Here that it is y square. Therefore, dividing by y square throughout, we get 1 by y square into dy by dx. It is 1 by y square into dy by dx. 1 by y square into y by x, and that is equals to 1 by x square. Nothing but transferring, we get y raised to minus 2 into dy by dx plus y raised to minus 1 into 1 by x is equals to 1 by x square. We call this equation number 2. And then we put y raised to minus 1 as some new dependent variable as z. Differentiating it with respect to x, we get minus y raised to minus 2 into dy by dx is equals to dz by dx. Substituting it in equation or transferring that minus sign, we get its value as minus dz by dx. Put this in equation 2. Equation 2 becomes minus dz by dx plus 1 by x into z is equals to 1 by x square. Multiplying by minus sign throughout, we get dz by dx minus 1 by x times z is equals to minus 1 by x square. Equation number 3. Here, z is a dependent variable whose degree is 1 and its differential coefficient is dz by dx whose degree is also 1, and therefore it is linear in z. Comparing, we get the value of p as minus 1 by x, q as minus 1 by x square, if as e raised to integration of minus 1 by x dx, e raised to minus log x. E and log get cancelled, we get x raised to minus 1, nothing but 1 by x. And therefore solution is dependent variable into if is equals to constant plus q into if. Dependent variable here z, it is not y, it is z actually, into 1 by x is equals to a plus integration of x raised to minus 3 with respect to x. Its integration is x raised to minus 2 by minus 2. Minus minus, it becomes plus. And therefore, we substitute the value of z as y raised to minus 1. Therefore, it is y raised to minus 1 into 1 by x is equals to a plus 1 upon 2x square as a required solution. Please like my video, share it, as well as subscribe to my channel, and to receive the notification, please press the bell icon. Thank you. Thanks.